A car is driving on a level road. The coefficient of static friction between the tires and the road is 0.9. What is the maximum acceleration of the car? Okay, first let's picture that situation. So we have a car, these are the tires for the car. That is the car. The car is on a road and it is accelerating. Let's assume it is accelerating in the forward direction. The mass of the car shall be m. Now, in order to accelerate in the forward direction, we need a force acting on the car. The net force acting on the car must be pointing in the forward direction. The only other object that is in contact with the car is the road. So the frictional force acting from the road on the tires has to be acting in the forward direction. Of course, there's also then a normal force acting from the road on the tires, and the weight mg is acting downward on the car. The first thing we need to do is, let's draw this as a free body diagram. I define positive y going upward and positive x towards the right in direction of the motion of the car. The car itself is then just represented by a dot at the origin of the coordinate system. Next, what we draw is all the physical forces acting on the car. So we have downwards, we have the weight acting, upward we have the normal force acting, and then we have the frictional force acting on the car. If we assume that there is no air drag on the car, these are all the forces that are acting on the car. Now we can apply Newton's laws. Newton's laws tell us that the sum over all forces in the x direction equals ma(x). And this is what we're looking for. We're looking for the x component of the acceleration. The sum over all forces in the y direction, that is ma(y). Now, because the car is supposed to stay on the road, so it's not lifting up, the acceleration in the y direction is 0. Let's look at our diagram. In the x direction we have, in the positive x direction we have the frictional force acting. That's it. There are no other forces acting in the x direction. And that equals m times ax. Now that is easily solvable for ax if we just would know what the frictional force is. Now, we know that static friction is less equals the coefficient for static friction times the normal force. Now, if we are looking for the maximum acceleration, we need to explore the maximum static friction. So that means the maximum static friction equals to μs times n. Now, if we would know n, then we could solve for ax. But we don't know what n is yet. So let's look at the y direction. In the y direction, we have acting in the positive direction the normal force, in the negative direction the weight, and that equals 0, because the acceleration in the y direction is 0. From that it follows directly that the normal force is equal to the weight. That's almost intuitive. So we can take this and plug this back into the frictional force. So the maximum frictional force equals μs times mg. So I plug this in, I find then mu s times mg equals m times ax. I can multiply this left and right by 1 over m, and what I get then is mu s times g equals ax. I can now calculate what it is. Ax, which is the maximum acceleration, is then 0.9 times 9.81 meters per second squared. Always provide the units when we use the value for the acceleration. And that equals then 8.3 meters per second squared. Note that the result that we obtained does not depend on the mass of the car. So the maximum